Friends, let us continue with our trigonometry. We are in the second part of our discussion of trigonometry, where we are going to learn some important basic trigonometric identities. The three identities which are very important in trigonometry are: the first one is sin square theta plus cos square theta is equal to 1. Second one is 1 plus tan square theta is equal to sec square theta. And the third one is 1 plus cot square theta is equal to cosec square theta. In our previous segment, we had proved the first identity in a different manner. Today, I am going to show you another method of proving the same identity but with a different method. This method is such that if you use one method, you can prove all the three identities together. And therefore, we are going to see today this particular method. Now for that, what we require? First of all, we require a right angle triangle ABC, where again we have taken angle B as 90 degree and angle A as theta. Now from our basic definitions, we know that sin theta is equal to opposite side upon hypotenuse. So accordingly, sin theta is BC upon AC, cos theta is adjacent side upon hypotenuse. Accordingly, cos theta is equal to AB upon AC because the side adjacent to angle theta is AB, and tan theta is equal to BC upon AB, which is opposite side upon adjacent side. Also, in our earlier definitions, we have seen that cosec theta is the reciprocal of sin theta, and therefore cosec theta is AC upon BC. Sec theta is the reciprocal of cos theta, therefore sec theta is equal to AC upon AB. And cot theta is the reciprocal of tan theta, therefore cot theta is equal to AB upon BC. These are the 6 basic definitions of trigonometry. We have first only found out them, written them and kept them aside. Whenever we will require them, we will be substituting them in our proof. Let us start now. To begin with, triangle ABC is a right angle triangle. Therefore, we know that we can always apply Pythagoras theorem in a right angle triangle. Let us apply Pythagoras theorem. It is the sum of the squares of the perpendicular sides. AB and BC are the perpendicular sides of triangle ABC. So therefore, BC square plus AB square is equal to hypotenuse square. We know hypotenuse is AC, therefore AC square. Now, depending upon what identity we are proving. For example, to prove the first identity, what we will do? We will divide this equation 1 with AC square. So, on LHS also, we will divide all the terms with AC square, and on RHS also, we will divide the entire term with AC square. On the left hand side, we have got two terms, BC square and AB square. Dividing both of them by AC square. So, we got BC square upon AC square plus AB square upon AC square is equal to. On the RHS, it was only AC square. When we divide again by AC square, we will get AC square upon AC square, which will get cancelled. AC square getting cancelled, we get 1. And here what we have done, BC square upon AC square is BC upon AC the whole square. AB square upon AC square is AB upon AC the whole square. And here, since AC square has got cancelled, we got 1. Now, BC upon AC. Remember, in our earlier part, we have already found out all the trigonometric ratios. So here you can see that BC upon AC is nothing but sin theta. Therefore, in place of BC upon AC, we will substitute sin theta. But since it's square, therefore we got sin square theta. Plus AB upon AC. What is AB upon AC? AB upon AC is cos theta. And therefore, in place of AB upon AC, we will substitute cos theta. But since it's the square of it, therefore we will get cos square theta is equal to 1. In this way, we prove the first identity and we'll say hence proved. The first identity has been proved. Now the second identity, which is 1 plus tan square theta is equal to sec square theta. We'll start again with the same equation. BC square plus AB square is equal to AC square, which is nothing but Pythagoras theorem. This time, we will divide the entire equation by AB square. Now you wonder, sir, why AB square only? Why not BC square? The reason is, if you require tan theta, see in our identity, we want tan square theta, we require tan theta, and you see that in the definition of tan theta, AB is in the denominator. Similarly, in the definition of sec theta, AB is in the denominator, and therefore we have to create that AB in the denominator. Hence, we are dividing the whole equation by AB square. So, BC square upon AB square plus AB square upon AB square equal to AC square upon AB square. Now, since AB square are same terms, therefore they get cancelled, and hence we get BC upon AB the whole square plus this got cancelled. Therefore, what is remaining now? Only 1 is equal to AC upon AB the whole square. We have taken square as common. Now, BC upon AB, as per the definition, BC upon AB is tan theta. Therefore, in place of BC upon AB, we will put tan theta. But since it's a square, therefore we will get tan square theta plus AB square got cancelled. Therefore, we got 1 is equal to AC upon AB is sec theta. Therefore, we got sec square theta. Rearrange the terms as we require. Instead of writing tan square plus 1, we can write the same thing as 1 plus tan square theta, and sec square theta is as it is. Hence, the second identity is also proved. Therefore, we write down hence proved. Similarly, the third identity can be proved by dividing the entire equation 1 with BC square. So, if you divide the entire equation by BC square, you will get the third identity, which is a self-study for you. Have you understood, my friends, this segment of our discussion? Thank you. Take care.